Hello everyone, this is Non-Daily Science, and I'm starting a new series today. This series is going to be based around science, and it'll be the first series on my new channel. My new channel, well, I haven't come up with a name for it yet, I just improvised. I said Non-Daily Science because, well, I don't really plan on posting videos daily. It's just not what I do. I'm too busy. I've got a schedule, like I'm pretty sure most people do. However, when I do post videos, they will mainly be based around science, or computer science, or coding, or some kind of education, maybe in history, because I find that interesting, and I know a lot of people like to learn history, even if it's not their kind of topics they've chosen to go into in life. Anyway, as I said, I'm starting a new series on this channel, and in this series I'm going to attempt to progress through a PowerPoint, a slide presentation about computer science and information and how you distribute information, how you compute information, lots of different methods of doing this. And you're going to learn that the easiest way to do this is with computers and electronics. So what I want to do is share some of my own knowledge about how computers function and how we can make one with a simulation. Well, I say simulation, but really I mean Minecraft. Well, before we get into learning or building our own computer, we're going to have to know what is actually in this kind of series, what I'm going to be talking about, what kind of things you will learn, how advanced we're going to be getting. So we're going to split this up into chapters, and hopefully I should cover a chapter in every couple or few episodes, and I hope that the topics covered in every chapter, I do get them covered per episode. So the first chapter is all about logic, and it's about, like I said, information in electronics, how you process information at a very basic level. So first of all, we'll learn how to represent information using different forms of different number systems. For example, binary. I don't know if you've heard of that. That's how computers talk. We might even go into hexadecimal. We probably will go into hexadecimal because that's quite useful, almost as useful as binary, but it's not used as much. The next topic in that chapter is logic gates. These are the things that do the main processing of information. They're like tiny little circuits that are made up of these things called transistors. I'm not going to start on. I'm not going to begin explaining this kind of thing yet, but it's, well, we might not even learn about transistors, to be honest. This is more about computing than electronics, but logic gates, I'll tell you now, they're made up of transistors, and they can compute information. They can process information at the most basic level in a computer. The second chapter I'm calling Basic Computing, and this is very, very basic. This isn't the structure that you structure modern computers with. If you structured modern computers with this layout, not many people are going to buy your computer because it's really difficult to use. As humans, we are terrible at deciphering binary. We're taught to handle numbers in base 10. We're taught to count from 1 to 10 to 20, and after you get past 9, you start repeating numbers, like 1 appears again. So you get 1 0, 1 1, 1 2. It repeats itself. Alright, so we got a bit sidetracked there, but we're going to talk about the second chapter, and I'm going to try not to get sidetracked again. So the first topic in the second chapter is arithmetic circuits. Now, arithmetic is essentially mathematics. There's many different names. You can call it what you want. Numeracy, literacy. Oh, sorry, I'm going a bit nuts there. But yeah, it's basically maths. What you learn that's arithmetic. So by arithmetic circuits, I mean circuits that do math for you. Like a calculator, you're not going to do something like 2,986 times 3,430. you're not going to do that in your head. You might write it down on paper if you're being forced to do it by your maths teacher or something. You must have a horrible maths teacher. She's going to make you do that. Or he, it could be a male maths teacher. I know I'm stereotyping right now. So generally, that's not really desirable if you're going to do an operation that big. You're going to want something else to do it for you. So that's the idea behind arithmetic circuits. You're going to design something using logic gates, in fact, that will do math for you. It will make your life a whole lot easier if you have circuits that can do math like that for you. The next topic in the second chapter is memory. Now, memory, it's essentially the memory you think of every day. You think of, what am I thinking of? I'm going to try and memorize some words for a test, or memorize a speech before I go into an interview. So that's what you think of when you think of memory. Generally, you think of, I'm going to remember to do this. I'm going to remember to use this much flour in baking my bread next time, rather than using all this flour and having really horrible, nasty, sandpapery bread. So that's the idea behind memory in everyday life. Although in computing, it's quite different. The computer doesn't remember by itself. It doesn't remember, I've done this wrong this time, so I'm going to remember to do this next time. Instead, in a computer, it just remembers information. You tell it what to remember. You have to tell the computer what it's going to remember and what it's going to forget. Otherwise, it'll get confused. In fact, it won't even get confused. It won't do anything. If you haven't programmed a computer to do anything, it can't do anything in general. So that's memory. You've got to tell a computer what data it can remember and what data it doesn't need. Random access memory, basically the same thing. You're going to save something into memory. You're going to tell a computer to memorize a piece of data. That's random access memory, also known as RAM, by the way. Then we'll be talking about the basic model of a computer. And as I was saying, if you built a computer at that kind of level, nobody in the world is going to want to buy a computer because it's just so difficult to use. Why would you build a computer if you can't use it? That's my point, really. Then you've got the third chapter, which is more about automation. So here you add, instead of going inside your computer and hitting loads of switches and stuff and making it all the cogs turn or stuff like that, if you're going to automate a computer, you want to have it like I'm doing right here. I'm typing keys into my keyboard. I can go da 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 da. And you have a key and you have letters on each key. So it's represented what you're entering into the computer. Say the letter S, the control, which does many things on a computer. All of these letters are all labelled, so you know exactly what you're sending into the computer. So that's the user input. That's part 2, that's the second topic. And the first topic of the third chapter is program memory. That's probably one of the harder things to explain. Program memory, that's basically where the code goes in. You know when you see, I don't know if you've seen The Matrix or any film like that, where it's all, you see all those zeros and ones. They actually represent commands, what the computer is doing. So coming into the series, you literally don't need to know anything about computing. You don't need to know what a transistor is, what a logic gate is, because I'm going to teach you all that. You don't necessarily even need to know how to use a computer. If you don't have a computer, that's fine. I'll explain the definition of a computer, what a computer is meant to do, what it did do, what it will do in the future. I'm literally going to explain everything from the very basics. So if you're interested in learning about this, then and you don't have a lot of knowledge about computing, then this series is probably for you. So here's some additional information as well. Some of my videos might be in collaboration with a YouTube channel called Bossman Lebai. I used to share a channel with him, I've put a few Minecraft videos on there, also science, computer science and things. So yeah, we might be doing video collaborations. The second thing I want to mention is that I don't have a schedule, so don't expect videos to come regularly. That sounds kind of bad on my side, but I've got quite, like I said, I'm a busy person, so I'm not going to be posting videos daily. That's why I improvised non-daily science. It can come any time, but you know, enjoy it when it comes.